All right, welcome to our next session. Good to have you all back for the afternoon. This session is called Really Remote Working, Virtual Reality Advances and Challenges. Thank you again very much to our day one sponsor, Dynetics. We appreciate your support. And without further ado, I'd like to introduce our moderator, Dustin Tyler, who is Director of Human Fusions at Case Western Reserve University. Dustin, over to you.
Hey, Jim, thank you very much. I appreciate it, and I appreciate the opportunity to talk today. And for those of you joining us, as Jim said, I'm the Director of the Human Fusions Institute at Case Western Reserve University, and I'm a Kent H. Smith Professor of Biomedical Engineering, Professor of Electrical and Computer Systems Engineering in the Case School of Engineering, and I have an appointment at the Cleveland VA Medical Center. So welcome to this phenomenal panel. Ultimately, the other people, the speakers are awesome. Entitled this Really Remote Working, we're looking at virtual reality advances and challenges. And so far today, some of the talks that I've seen and a lot of what we hear about recently are advances in technology for space exploration, development for human travel, working, living, and even now we hear about vacationing in space, and automated systems for aiding human exploration in space. Inherent in a lot of these advances, though, is this concept of the notion that the human is physically limited by its biology. And to grossly simplify a lot of the space development, we are either developing technologies that's separate from the human to collect data and send it back to us, or developing technology to make environments hospitable to humans, such as the space station, space vehicles, or environments on other terrestrial places. That's sort of the focus of development. However, virtual reality, or really more accurately for the conversation today, is telepresence technology, can amplify the human. And what I mean by amplify the human is that it's extending our presence beyond the boundaries of our skin, to extend our capabilities beyond the limits of our muscles and allow us to survive or be in hostile environments. Telepresence is really the process of allowing our presence, that is our sense of self, our mind, our capabilities, and our actions, to exist elsewhere from where our biological body is. So I'm excited to host this really distinguished panel of individuals in which we're going to explore the several advances and aspects, the future of telepresence, and the evolving revolution in the idea of what it means to work in space. So our panelists today include, basically, I'll start with myself, introduce some of the work we're doing in human fusions, and particularly the direct and neural connection between humans and technology to create this idea of embodied or symbiotic relationships with technology. Dr. Veronica Santos, who's the Associate Dean of Equity and Diversity and Inclusion at the Samueli School of Engineering at UCLA and the Professor of Mechanical and Aerospace Engineering at UCLA, will introduce and talk about advances in feeling robotics for operation harsh environments and that are capable really of serving as an avatar system that could be thought of as a surrogate for the human body in many ways. And Dr. Christopher White, who's a General Manager and Managing Director of Special Projects at Microsoft Research, will introduce some of the latest advances in virtual and augmented reality, or holoportation, and the different technologies around that. To round out our panel, we have two experts to discuss the critical aspects of humans in space, particularly considerations of the risk, benefit, and ethics of putting humans in space, including the care of the astronaut and the effects of space exposure on that astronaut. So Dr. J.D. Polk, who's a Chief Health and Medical Officer for NASA, will talk about the ultimate in remote medicine, if you will. To date, NASA has an impeccable record, but somewhat this has been managed by choosing extremely healthy individuals with tight health requirements prior to going to space. However, as space opens up to more people, luck and extreme planning will become less effective. And so how is the care of the astronaut handled today? How is telemedicine employed? What are the remaining challenges, such as communication delays and ability to perform procedures remotely? And how can we improve the care of the astronaut? And finally, Dr. Beth Lewandowski, who's a biomedical research engineer at NASA Glenn, will talk about the risks and effects of space exploration on the human body when all goes well, let alone when failure conditions occur. This will open up a conversation about the risk and benefit ratio of the human-related space travel and a context for developing risk-reward paradigms for the technology to enable advanced telepresence over physical travel to space. So despite the impressive record, putting humans in space entails exceptional risk. And in most other endeavors, this level of risk may actually be considered unacceptable. And so how do we address this risk-benefit ratio in space exploration? So each of the panels have about 5 minutes to introduce and talk about the respective areas, including the advances, the challenges, and the risks of that technology. And this will leave us about 30 minutes as a panel discussion. And I hope that their introductions and what we talk about, in the outstanding cutting edge work that they're doing will engage questions from the audience, and we can really look at a lively discussion from this panel of world-class experts and potentially disruptive technology that we're going to be talking about. So if we can switch the slides. I will start by introducing and talking about, so we'll go to the next one, please. So just briefly, the work that we're doing at Human Fusions at Case Western Reserve University, I've spent my career really in developing technology that talks directly to the human nervous system. And so rather than using our hands and using technology through our physical system, we're working on ways to connect directly to the brain, if you will. My work has been predominantly in the peripheral nervous system. And of course, many of you may have heard of work that's going on with either surface recording or direct brain recordings of work that people are doing. In my view, the advantage of the peripheral system is you actually include the entire human system from that point in. By connecting to the peripheral system, we are engaging every aspect of the neural axis of the human, human decision-making and really the human intelligence. So coming in from the peripheral nerve, you're engaging spinal cord, cerebral cortex, the cerebellum, all these elements that go into controlling the human, making decisions. And then by recording that from the muscle or from the output, which is at the end of the system, all the activity and decisions made by the human are engaged. And so what we're doing then is looking at how do we now go from a virtual reality, which is putting on goggles and, essentially engaging by using technology, to really what we think of, we're calling neural reality, which is connected information directly to the human through a nervous system. And from this, we think that we can amplify the human, as we talked about earlier, by now actually giving us not just a virtual sense of being somewhere, but true telepresence. Because now, when a robotic system that's remote were to touch an individual, for example, in healthcare, that data coming back from the robotic system is directly fed in as though it's this individual's hand. So now you actually feel the environment you're at. And so now the presence is as though you're at that environment. And so we think about this in terms of healthcare, or even obviously maybe space operations, space activities. And so this work has been demonstrated. We have now over 10 years of experience in just thinking of limb loss, where we have a direct interface to the peripheral nerve. And so for individuals that have limb loss, we basically take sensor data in the prosthetic hand, connect it back to their arm, and they feel their hand. And one of the quotes that I'll give you from our subjects that I think is fascinating to this work is that without sensory feedback, without doing this work, the prosthesis is just a tool. It's on the end of their arm. As soon as we turn on that sensation, however, they start to refer to everything as their hand. Right? Even though they've lost their hand long ago, this becomes their hand doing a task. And what's interesting about this, to extend that, is that really the prosthesis is a robotic system. Right? This is simply a robotic system attached to the end of the arm with sensors, and that's just data flow. So now we can actually take the data from a robotic system, send it over the internet, send it over communications, provide it back to the user, and they essentially will feel their hand wherever it is. So we can place today somebody's hand in space, or as an example we've been doing with my colleague who will introduce next at UCLA, we actually are connecting robotic systems in UCLA across the country, and data coming from that back to an individual in Cleveland who's wearing now a glove version of this interface. It's still stimulating the nervous system. So they feel things on their fingertips, even though they're using external stimulator. They feel what's happening in UCLA, and as they move in Cleveland, they're moving the robotic system across the country. And so they see as though they're in this room, and they feel as though they're in this room. They essentially are in this room, in this behavior. And additionally, the people in LA are experiencing this presence. So we're looking to how we can extend this. What can we do for space exploration? What can we do in the telepresence to advance this technology? And so with that, I'm going to turn it over to talking about the robotic systems and really what are the technology we need to enable this on the robotic side, to my colleague, Dr. Santos at UCLA. So if you can advance this slide, please.
Thank you, Dustin. Well, as Dustin mentioned, I currently serve as the Associate Dean for Equity, Diversity, and Inclusion in Faculty Affairs for the Samueli School of Engineering at UCLA. I'm also a professor of mechanical and aerospace engineering and bioengineering, and I direct the UCLA Biomechatronics Lab. So our lab is dedicated to improving quality of life by enhancing the functionality of artificial hands and their control in human-machine systems. So to this end, we study human grasp and manipulation, tactile sensors and tactile perception, and robotic grasp and manipulation. In particular, we focus on giving robots a sense of touch. So alongside collaborators like Dustin, we can provide this sense of touch directly to an individual with limb loss or to a human teleoperator of a remote robot. We can also provide this sense of touch directly to a robot so that it can make semi-autonomous decisions under human supervision. And since many of our tactile sensors are deformable, like the human fingertip, we develop machine learning-based models for pattern recognition so that we can transform raw sensor signals into higher level abstractions such as shape, rigidity, roughness for decision making. Our lab is interested in the entire continuum of human-robot systems for grasp and manipulation. These can be robots that are physically attached to the human body, like neuroprosthetic limbs, or robots that are separate from the human body, such as robots mounted on wheelchairs for assistive living, on the manufacturing line, or supporting our servicemen on the battlefield, or our astronauts in space. We are currently developing tactile perception capabilities for activities of daily living, as well as in extreme environments, such as in granular media and underwater at depth. And as Dustin mentioned, we are collaborating on an exciting new multi-university project that aims to transcend the physical boundaries of the human body. So my lab thinks about touch for robots and how important touch is for robots, but we believe that touch is also essential to the human experience and what it means to be human. So we recognize the importance of robots as teleoperated tools, and we are excited at the prospect of extending the human experience through the use of physical robot avatars that are endowed with a sense of touch. The dream is to move beyond this traditional paradigm of teleoperation in order to achieve an embodied telepresence. And I'm looking forward to our discussion today. Thanks.
Great. If we can advance the slide, and Dr. Chris White, please.
Thanks. Hi, everyone. My name is Chris, and I lead special projects at Microsoft Research. At Microsoft, we are constantly exploring this relationship between humans and technology. And a component of that is the physical relationship between the humans and technology, which, as has been mentioned, depends upon where they are. And so a key focus at Microsoft is presence. And by presence, we also have developed what we call Holoportation, and that's soon to be available as part of a product area called Microsoft Mesh. And the idea is that it enables you to project yourself as your most lifelike, photorealistic self in mixed reality to interact as if you're there in person. And what that means, if you look at the graphics on the screen, it means that we're capturing, fusing, texturizing, rendering views of live, volumetric, dynamic 3D models of yourself. We use open source and commercial off-the-shelf software wherever possible. For example, we could use better compression with custom codecs, but we get reasonable compression by massaging our data to use hardware-based video codecs at lower cost. And so the broadness of adoption and sort of ease of use is a central criteria for our design considerations. And we're continuing to explore the technology improvements here at each stage of these processing pipelines. For example, to enable applications like telemedicine that we've heard about in remote areas of the world and beyond. And for example, if you think about telemedicine, a 2D window, a video window, many of you maybe during COVID have had a telemedicine encounter on 2D video, which has really been an amazing opportunity during the pandemic to understand medical knowledge and interaction. It lets a doctor interview a patient. It lets a remote doctor who's tethered to a single point of view get a perspective. But 3 dimensions, really live, volumetric, all the way around a person, lets a doctor examine a patient. It lets a remote doctor move around the patient naturally, as though they were in person, to rapidly identify problems. And there's different kinds of medical relevance, as we'll hear in the next speaker about kind of medical challenges in space. In this case, it allows for kinematic assessment of simple actions like brushing teeth or moving limbs or moving parts around a spacecraft. It's enabled by the emergence of these many high quality, low cost cameras and depth sensors. The sensor space has become proliferate with opportunity. And it offers a potential for something like remote field guides, like we heard earlier, with medical or other expertise to help with problem solving while in space. And we're approaching validation of these concepts through mechanisms like clinical trials. For example, we're working on a clinical trial called Comparison of 2D and 3D Telemedicine During COVID-19, where we expect to find, for the first time, definitive medically relevant clinical trial results about 3D telemedicine with our partners in Europe and Africa. But as we look forward, we have to consider an even more challenging frontier that we heard about from Veronica and Dustin, a frontier around neural engineering, where we add neural sensors like EEGs and fMRIs, as well as possibly invasive sensors in the future. We add those to things like RGB cameras and other depth sensors. And we have this question: can we use neural signals as a new form of interface to increase productivity and satisfaction? We intend to go from the current approach to brain-computer interfaces, from telepathy to something more like empathy. From our perspective, there's a need to build out an empathic computing system that enables experiences that evolve in harmony with our mental state to allow us to take control of our digital well-being. And so we're pushing this boundary from an explicit input modality to an implicit mediator of our overall interactive experience, spanning aspects of learning and well-being and collaboration. The idea that each individual can be both happy and productive at work. And this includes activity accelerators, things like support for implicit evaluation of technology and software applications, training material, as well as accessibility enablers like adaptation to neurodiverse brain activity. If you think about the perspective of remote work, of really remote work, of augmented reality, so not just VR, but XR and everything in between, from our perspective, empathy is central to the future of work and interaction in space or on Earth. And so we believe that by pioneering empathetic and empathic computing, we can truly achieve Microsoft's mission, which is to empower every person and every organization on the planet to achieve more. And the thought is that by understanding the ecosystem of partners, work happening in national labs, at NASA and universities, bring together complex proof of concept systems to show possibility, and then driving cost low for broad adoption gives us an opportunity to realize this kind of future where we can be many places, but we can have impact in many more at the same time. And now, please advance to the next slide.
I wish we had more than an hour. There's so many things to talk about from all of this. So Dr. Polk.
Yeah, thanks, Justin. First, let me tell you what we do now. Obviously, we monitor the astronauts in mission control, and we get a lot of data down, and some pretty impressive data on the back of their eye. The astronauts may look, do a view and look at the back of their retina, and we can get that down on our devices to look at if they're having any what we call optic nerve edema or swelling in the back of the eye of their retina. But also, going to Chris's point, we just recently accomplished an experiment where we did a holoportation of the flight surgeon onto the ISS, where the crew members could see that flight surgeon in their virtual reality goggles, and did the first virtual handshake, if you will, between the flight surgeon and the astronauts on board. Where the challenges will be is as we get further and further from Mother Earth. As most of you know, with Mars, there's a 20-minute lag in communication. And so being able to get that kind of signal back to Mars is going to be a challenge. And what we think we will do, and what we are forecasting, is to be able to split this up into what does the astronaut need to do autonomously on their own right now versus what can they have reach back capability for. And even that, to the augmentation of the astronaut on Mars could be paramount. There's so many medical procedures that you would need to know, and that residency doesn't exist anymore. If you think about the days of old when you had a general practitioner that did everything, the person that's going to Mars, if you send a physician there, they have to be part OB-GYN, part orthopedic, part dentist. There's a whole massive amount of information to know, and they may not be able to know it right away or have it at their fingertips. So being able to call up and having the computer augment them or show them a procedure real time while they're doing a procedure, or to overlay the landmarks in virtual reality form over top of a patient to walk them through how to do the ultrasound again, because the last time that they did one or learned one was 2 years ago. Those are going to be important things to help augment the astronaut while they're on Mars, as well as the reach back capability to the experts for things that are not of emergent or time of the essence type things. And if you can imagine, on this analog, this is on Devon Island in the Arctic. One of the experiments we looked at was not only how do we rescue an astronaut, how do we, if an astronaut has fallen down a crater, what do we do with them? How do we transport them? But also, how do we get that data to the caregiver and heads-up display in the astronaut's helmet? So I could actually look at you and you would Bluetooth your suit parameters with your oxygen, your CO2, your EKG up in my heads-up display. So augmenting the information, augmenting with virtual reality on Mars itself, and augmenting with reach-back capability are all things that we are entertaining and looking at as we forecast what we'll need for Mars missions and beyond. And so with that, I'll stop and go to the next speaker.
Great, thank you. And I have to say, it's one of my favorite slide pictures. It says so much in one picture. That's one of my favorite when I saw you send that. Dr. Lewandowski.
Hi, my name is Beth Lewandowski. I'm a biomedical research engineer at NASA Glenn Research Center. Over the years, my research has focused on understanding the hazards astronauts face during spaceflight. The hazards include exposure to gravity fields that are very different from Earth's gravity, exposure to space radiation, living in a hostile enclosed environment, isolation from loved ones and daily life, and travel to places that are very long distances from Earth. My research has looked at the impact of these hazards on astronaut physiology, health, and performance. NASA currently uses a wide range of technologies on ISS missions to counteract physiological effects and to minimize health risks and to enhance performance. NASA is also working on technologies to be used during long duration space exploration missions. And NASA is looking to determine what technologies need to be developed or are existing and can be used. But unfortunately, the inclusion of these technologies comes at a cost to the vehicle and the mission. And these costs need to be balanced against the benefit of the technology, how it provides reduction in risk versus the costs to the vehicle. So I'm currently involved in some projects here at NASA that are developing tools to perform these types of trade studies, and also tools that can be used to optimize the types of technology included within the space vehicle through minimization of astronaut health and performance risk.
Excellent, thank you. So if we can, put up the panel at this point. I think those are for slides. This was not meant to be a presentation per se, but a conversation. So for one, I think, Jim, if there are questions, please break in and give us the questions from the audience. But I have a suspicion that there'll be plenty to talk about amongst ourselves. So I have to break in as we go. But when I listen to the group, one, there's a lot of cool uses for this type of technology. And in many ways, I look at this, and certainly everybody can give me their opinions as well, but I look at this as sensor fusion in many ways, right? So how do we, and I think Chris said it very well, right? We have lots of advanced sensors now, and we are finding new ways to display them to the individual. And we're finding new ways that technology can enhance the individual, whether it be by training or experience, right? Sort of an on-the-fly learning, as Dr. Polk said, whether it be a 3D visualization to basically cheat on the exam, open book notes, test for what you have to do. And I look at a lot of this as we add tactile information to this and haptic feedback. We know from neurology and when we, just in basic learning, by adding that full sensor fusion, we actually do better at different tasks. And so I feel, I think that the interest for me on this panel and getting everybody together is, how do we look to the future of this sensor fusion where we get best sensor information? How do we extend the capability to operate or move in different areas? So, around that, I guess I'll start off by kind of going through some questions here to the panel, and by all means, even the panelists jump in and I'm sure I'm going to have millions of off-script questions as we talk, and I want everybody to do the same thing just to keep this free flowing. Let me start with Veronica. You said autonomous robots, have been long considered sort of technical solutions for this dull, dirty, and dangerous tasks, right? So we've obviously space is dangerous, and we talked about different things. If we're moving towards human-centered symbiotic relationships, between the humans and robots as one aspect of where we're going, the sensor fusion and these ideas of telepresence. What should we take into consideration with respect to autonomy and related issues?
Thanks, Dustin. Well, I always envision a human in the loop somewhere in human robot systems. So if you hear me talk, you'll hear me be very specific about semi-autonomous robot behaviors, because I always feel like there should be a human in the loop somewhere, because we have the experience, the innovation, we know how to game the system even when the robotic system may not be fully capable, as capable as we are as humans. In a shared autonomy system, the level of autonomy that the human and the robot will each have, I think, is going to depend on the application of the system and the level of risk involved. So, for example, a robot avatar that drops a cup in the kitchen is going to be much more acceptable than one that drops tools during a life-saving surgery or a time-sensitive search and rescue mission. And so for structured environments and repetitive tasks, I think a high level of automation is probably tolerable. But in systems where the human seeks a very high level of control, as with prosthetic limbs, I think that it's more valuable to give the raw sensory feedback and that multimodal sensory feedback that you talked about directly to the human, so that they can learn these new skills through their own embodiment. It will just become part of their new self.
Yeah, appreciate that. I maybe push this to Chris and the rest of the panelists as well. And I'm fascinated by the idea of machine learning associated with human learning, right? And so, Veronica, you've talked about this I like the terms of a structured versus unstructured environment, ultimately, where autonomy is much easier if everything is known ahead of time or preconceived places. So I'm kind of curious, even with Microsoft and a lot of focus on machine learning nowadays, and how do you see that engaging with the human now in the loop directly? So what do you see the advances of that combination?
Well, I think you really nailed it from the opening, Dustin, about sensor fusion, where there's a question of both what observations of a person or the environment or a set of people do you need with enough fidelity to inform decision-making about what kinds of outcomes. And you're going to have a different setup if it's a medical situation versus a mechanical problem versus the need to really extend your physical presence into a different place. And so I would say what you just described is a really great framework for asking that question, depending upon a prioritized set of scenarios that were relevant to, say, a mission. So I would think of a mission basis describing that priority, and then the sensors needed to complement and sort of fulfill that. But you're right, the role of modeling, whether it's machine learning or sort of a mix of things, is extremely relevant. And it also depends on scenario. Like, for example, a very popular thing to do now is to learn these volumetric models. Like in the slide I showed, there were different glossy representations of meshes, of triangles that represent what a person would look like, the segmentation of their background. All of us are familiar with Zoom and Teams doing that kind of foreground, background segmentation. And those are creating, a model that then gets reconstructed on the other side. Now, there's a question, how much smoothing do you do in the model? All of you have also seen, I'm sure, glossy magazines with like airbrushing. You can do all kinds of machine learning based airbrushing, but if your problem is a medical one and there's a wound, you don't want to airbrush and smooth over the wound. You need, as Veronica just said, you need the raw feedback. In that case, it's not because it's into a human where the human's neurology and neurological system can model it and like embody it. But in this case, it's for an expert to interpret it. And if you give them back, the wrong sensor data and the wrong modeled outcome, you're not going to get what you want. And so I think that those questions you mentioned are right. And I would imagine that Dr. Polk has other perspectives on what's medically relevant to have at what timetable. And in general, I think these are complicated issues that need a mix of expertise to come together.
Yeah, next I was going to ask Dr. Polk to kind of comment. One of the ways I look at the machine learning and the human in the loop is even our own neurological system is hierarchical, right? So when I think about moving my arm, I don't think about coordinating all the muscle activity to do that. And so, I could see we're at one level. And you mentioned machine learning as making models for data compression, but also for sensory feedback and prediction of behavior as a time lag sort of fix as well. But kind of curious, Dr. Polk, in terms of the ideas that we use a lot of machine learning now is becoming very big in terms of also helping in diagnosis, for example. And so I guess in both procedural side as well as diagnostic side, how does this fit in sort of this extended reality, if you will, in trying to extend medical care, beyond physically in front of you?
It's going to be extremely important the further we are from Earth. Right now we have the luxury of sending that picture, like I mentioned, from the back of the retina to the best ophthalmologist in the country, or sending an X-ray or an ultrasound to the best radiologist in the country. But when you're on Mars, you may not be able to wait the 40 minutes for that answer to come back, or an hour for that answer to come back, if you're in a crisis. And so being able to have that type of machine learning where it already knows what the diagnosis is. It's got millions of examples of data of a chest X-ray or the back of the retina, where it can make a comparison right away and give you an augmented diagnosis, or tell you if your diagnosis is correct, or other things that you might consider in the differential diagnosis. I think will be very important for that person to consider when they're on Mars, and to help augment them.
That's great. So I have there's a couple of questions coming in, but I want to follow up on one more thing with the panel. Then I will open for questions from the audience. But one of the other things that I think we're on the cusp of, at least the work that we're heading towards, has been adding the tactile feedback directly. And something that Chris has hit on, and I think is relevant to medical care, and Beth actually talked about this in terms of personal interactions, this empathy or this connection business. And I will say that from my perspective, in every person that I've ever talked to about getting a prosthetic arm, when I was an engineer, before I became educated, I thought they would talk about the prosthetic and how functional it was. What I got educated on is every person I talked to, the first thing they said is they want to hold their wife's hand or somebody's hand. And so, I think from the empathetic perspective, I think, there's so much that you can do with sight. And we know from phenomenology and from other people that study human interaction, the eyes and the movement of the head is important for connection, but also just that physical touch and the nonverbal communication things that happen. So I'd like to sort of tag a few minutes. I think, Chris, you've talked about empathy, and I'd like to hear from Dr. Polk on the importance of that, as every physician says, the laying of hands, the actual touch in that work and feedback. And then Beth, in sort of the isolation aspect that you talked about in space exploration. So maybe, Chris, I'll let you start.
It's a great, Dustin. I'm a fan of the haptics research area. I wish I were smarter in it, and I'm grateful that there are a lot of biomedical and neural engineers that are really diving into that interface between different aspects of the nervous system and ways to augment with sensors and actuation. I think from my perspective, as you also pointed out, that we look at machine learning not just from a compression standpoint, but we look at machine learning as a way to model all kinds of issues, make recommendations, make diagnoses. And as Dr. Polk mentioned, if you're on Mars, maybe you don't have the luxury to wait. And so you're willing to take a lower quality model-based decision because you've got no option to wait for a person to get the information and come back. To talk about haptics and sort of feeling, I really think that you nailed it as well. But my view is about presence from a different perspective. And so rather than tactile feedback, our perspective is around eye contact as a starting point, where we know that we've all been on Teams and Zoom for a year. Everyone's got the slightly downcast eyes, or you're told to stare directly in the camera and it kind of weirds you out because it's above your screen or something. If you're lucky enough to have the right kind of equipment and bandwidth to do this kind of work, but anybody who's had a really sensitive issue, or needed to create a new relationship or establish trust, without eye contact, it's actually very difficult to do that. And so we're trying to augment these kinds of sensor-based approaches with cameras behind translucent glass, and ways to fuse different kinds of sensors into showing the eye contact in a way. So I hope that will be a stopgap as haptics get more mature, because software is very flexible to make very quickly. And so that's a priority for us in the near term, but really curious to see what the rest of the panel has to say.
Yeah. Veronica, I wonder if you might, before we go to Dr. Polk, comment on our recent experience with the vision and the connection of eyes.
Yeah, I thought it was interesting, Chris, that you brought up eye contact, because just a couple weeks ago, we were running this experiment with the robot avatar at UCLA, researcher at Case Western, and just to mess with the student in my lab, the student in Cleveland, was using the camera and the head movements, his own head movements, to make eye contact in different ways with my student. And they had a moment. We interviewed the researchers afterwards, and the students in my lab did comment that it felt like, they were looking, even though it was a camera that we knew we bought off the internet. Like, it really felt like there was someone back there, and there was a playfulness, and that added to the rapport, even though these students have never met in person.
Yeah, this project is a product of Zoom, believe it or not, all the way through. So, and Dr. Polk, I wonder if you might talk about your thoughts on this, and then specifically I'm thinking about the importance of physicians and tactile connection. And the other side of it is on Mars with the pulling up of information. How much would it or wouldn't it add if, say, for example, you also had smell or touch to that, the ability, if you show them to cut somewhere, but don't tell them how hard to push when you're cutting, or something of that nature, things that surgeons learn, right, through experience. I wonder if you could talk about the broader sensory component.
Yeah, you're hitting on something that's close to my heart. When I was the dean of a medical school, one of the things I really pushed for the students was to learn physical diagnosis. Unfortunately, we get so very often I've seen students and residents interview a patient from 3 feet away, and the stethoscope never leaves the pocket, and they think, oh, we'll get a CAT scan. Well, actually touching the patient can actually give you a lot of information. And a patient with a pneumothorax, for example, you can feel the air subcutaneously just below the skin once it escapes the lung, and you don't even need a chest X-ray for that one. It's amazing. You feel what feels like Rice Krispies underneath the skin. So being able to have that kind of tactile feedback is important. But for the astronauts as well, that human connection. Imagine if you're on a Mars mission for 2.5 years, missing some of those family moments, the birth of a child, the birth of a grandchild. And so being able to be there virtually, but also, tactily, feel like you could reach out and touch them, or the smell of, most of us know the smell of that baby shampoo on the grandkid, that kind of thing, that, it really brings them back home in a very different way, and allows them to connect that a store and forward video wouldn't do. Adding some of those elements will help them connect in a more emotional way. And as most of you know, most of our memories that we have, the olfactory sense is a very strong one. I can't smell peanut butter cookies without being immediately transported back to my grandmother's kitchen. And so, those little things actually do add empathy and add to the psychological health, especially when you're really far away from Earth.
Yeah, you can imagine a day where you're holoporting a message and holding your wife's hand. So even though, rather than just recording a picture of her doing something, you're holding her hand, even though it's 20 minutes delayed or whatever, it's a whole different experience than actually just seeing a message, what's going on. As you said, smell the baby's hair, which, depending what the baby did right after, is pleasant or unpleasant memories, but that's a whole other story.
Yeah.
So, Dr. Lewandowski, I wonder if you want to add some comments to this based on sort of your experience with the effects of space exploration and the value for this.
Yeah, sure. So, the astronauts that are on ISS, they're very close. They can see Earth. They can talk to people on Earth with very minimal delay. And their psychological well-being stays, pretty well intact. But when we think about the hazard of isolation and going so far away from Earth, when we talk about Mars missions, that's a whole new game. And the technology is just really going to be important for supporting the astronaut and helping them maintain their well-being. Some technology that is possible that could be supportive to them is the exercise device. So currently the astronauts exercise on ISS to counteract the bone loss, muscle atrophy, and cardiac capacity loss. But that's also, exercise is also, very beneficial for behavioral health and mood. So, making sure that we have an exercise device that is enjoyable for them, possibly incorporating feedback to, help with motivation. Those are some things that can be done to support the astronaut with technology.
Excellent, thank you. I'm going to finish this out and then take some audience questions here, but I wanted to kind of put one of my experiences as far as we've talked about machine learning and automating sort of responses a bit. And I think the glossy you talked about, Chris, one of the things that even I experienced with working with our subject with limb loss, and then we've had some of this with the robotic side, is just I was amazed to me personally when I asked them, like, how do you shake hands? Because they had their left arm was the one, or their right hand is the one they had lost. And, I said, well, I maybe close it a little bit, but, because I don't have any feedback, I don't want to crush the person's hand. So I did that shake, and it was that proverbial wet fish. And then I said, well, just go ahead. You have sensation now. Just squeeze my hand. And two things stood out. One, that was suddenly a handshake that felt like a person, partially because there was a better pressure. But the other thing was that really struck me, and I think this relates to how we convey the human experience, is that it was as much about the pressure modulating. So as they were holding my hand, it was not a perfect grip. And in fact, that really had a huge impact as to how I interpreted that connection. Rather than a device, I was now actually interacting with the individual. So I think it goes to a lot of these things where even if we're compressing data, I think, as you said, right, the eyes are pretty critical. We probably want those high resolution, the body maybe less so. Your non-human or your very humanistic nature is going to be important in different interactions. So one of the things that we're working with, and I think is important, is that we not just do the engineers and technical, but we include the phenomenologists and sociology folks as well in this work as we develop these to understand all these different parts, and the healthcare physicians. So with that, again, unfortunately, we only have an hour. I'd love to even explore this topic. Let's move on. So I think there's at least a question or two from the audience at this point. So go ahead, Jim, if you can maybe help us out. Give us
Yeah, sure. No, absolutely. So, a couple of questions. I mean, well, what you were just talking about, the handshake and everything. And I think about, well, every once in a while, mine's kind of cold and clammy, depending on what I've been doing that day. Is that a component of all of this? Because you guys talked about smell a little bit too, and how powerful that can be. So what about just acknowledging and anticipating and incorporating all of the senses, so smell, feel, the moisture and things like that, how big of a factor does that become? And which of those is probably the biggest technological challenge to overcome in this kind of a thing? So I don't know who to turn that over to, maybe Dr. Polk, maybe you could start on just kind of, the importance of it, and you too, Beth, the importance of those sensations for actual telepresence.
Well, I can't speak to the technological aspects as to which one's more difficult, but certainly, as you all know, communication 70% is nonverbal, and so you've got being able to see someone's reactions, or being able to hear someone, feel someone, the scent, all of those things work together to give you, almost, I guess, a sensory modulation, to use Dustin's term, that you wouldn't have otherwise. And they really do add to the overall, impressions that someone gets. You get a lot, when you are tasting food, for example, or smelling food. A lot of it of taste is olfactory as well. And so there's a lot of different feedback there that give us the ability to not only assess a patient, but the ability to communicate and connect with folks that are far from home. I think that'll be really important for people, especially as they reach back to their home and their family site. As folks were talking, I was thinking, what, if you're on Mars and your parent is about ready to pass away, how important that would be to be able to hold somebody's hand, even if there was a delay in doing that. But to be able to connect in that kind of real way is a very human thing.
But even like thinking of COVID, right? How many people dropped off a family member at the emergency room and never saw them again? I mean, never saw them again. That's I mean, it's kind of horrific to think about, but that's the kind of thing that was happening. And it's kind of an analogy of what we're talking here. You know, briefly, just from the technological standpoint, and then turn it over to others as well, is that, so one of the reasons that I think, you know, in the work we're doing here is the neural side, right? So ultimately, every sense we've just talked about has some neural substrate somewhere. The technological challenges, of course, are how do we interact with that and where? And there's some easier than others. But, you know, we've looked at tactile being the next most important in the sense that really presence comes from a lot of ways of visual tactile synchrony. You know, when you see something and feel it, it becomes real and you're kind of connected to that environment. And I think we have to think about this in the context of sensory fusion, right? I mean, essentially, we all experience one world. And so all that sensory information is engaged internally, and the brain is making decisions about weighting different factors of sensory input to give us a vision of the world. Optical illusions are a classic example of when senses don't match exactly what the brain is expecting. It fills in the gap sometimes in weird ways. And so I think all of this, we have to consider a lot of the neuroscience as well. And what are the things most important to synchronize, and which ones are usually in the brain's prospect lower in their thing. And so, you know, in virtual reality, for example, vestibular is probably a very important thing to gather, because people get sick when their eyes don't match their ears, right? Their inner ear and where they're feeling. In holoportation, maybe not so much, because you already have vestibular presence where you are, but visual tactile synchrony make it real. And so I think the situation is going to help define which ones are more important. And I think technologically, you know, I think, like, for example, in the HoloLens, right, we're trying to make form factors that work for people. And I think visual prosthetics on a neural level are not nearly at the same resolution. But at tactile, you know, we have approaches to the nerve now that are untethered. You don't have to wear this big backpack. It's actually part of who you are. So I think there's I think we're on the beginning of all these questions, which is sort of where I think the excitement for the future is, honestly, is we have a lot to develop here. And, you know, this is one of the things that we're looking at here in the teams with Human Fusions. I hope to continue to grow on. So I'll turn it over to maybe Chris. I see you turned your mic on. You're ready to go.
Yeah. And then I see Veronica just came off mute as well. So happy to hand it off. I just wanted to comment on your tech feasibility perspective, but from maybe the non-neural side, non-biomedical side. And I guess but also just to reinforce your point and Dr. Polk's, to me, this is about relationships. You know, establishing relationships is something that everybody's doing all the time. Doing it remotely is also a challenge, and we have, you know, constraints. And so we're trying to understand what constraints we can relax and which ones we can get rid of. And so one perspective that we have is not from the sense perspective, but from the capability perspective, where we go from 2 dimensions to 3. And so we're adding a dimension. It's as simple as that. It's still a video, but it's a video that has a 3rd dimension. It's not quite like a sense, but it's augmentation to the 2D, and what opportunities that open up for you to do more things with. That's kind of one perspective about it. Mm-hmm. And we think that there's like this kinds of, you know, interaction based on the eyes. There's another way that we can, you know, use technology to modulate the experience without addressing the body necessarily, just knowing where the eyes are looking, knowing what's being rendered. And ultimately, this is about, you know, capturing, modeling, and rendering, where I'm saying that abstractly. And I can talk about rendering a video. Rendering a smell, very difficult. You know, I'm not even sure what that means. I'm out of my area. You know, haptics, I can kind of get it with a touch. But from my perspective, that has to happen in some way with some view of modeling. And so, as you say, maybe the fusion of sensors into modeling is where the action is going to be in the future. But I'm sure Veronica has a point of view as well.
Yeah, just a couple comments to tie together what Dustin and Chris have said. When Dustin was talking about neuroreality, I mean, some researchers in that area have said that reality is just a stable hallucination. So imagine if we could provide a stable hallucination for well-being just by dialing it in, you know, at the neural level. That would be amazing. Until we get there, there was a question about the tech part. And I view the tech as having 2 different regions. There's the tech on the local side, where we need to collect all the information to figure out what we need to render on the remote side. And I think the tech for collecting, you know, sight, sound, smell, even senses that animals have that humans don't, like proximity sensing, we have much of that technology already, but it's the rendering side, it's the display side that we haven't figured out. You know, we have screens for images and videos. We can provide a speaker for sound. Touch, we're getting there, invasive and non-invasive. Smell, I'm just imagining someone with a lot of little, you know, pipettes of different chemicals, kind of squeezing them in front of someone's nose or on their tongue or something. I'm not familiar with how advanced we are there, but I think it's the rendering side that where a lot of the tech advancement, miniaturization, power has to happen.
And there is work on people that are looking again at neural substrates for, once the sensors in the nose pick this up, it's just information on the nervous system. And again, the rendering is the problem, right? From even the neural question is how do you render that data well enough that it's good? And I think, in that regard too, there's also a learning capability we have to not forget, right? So, your brain is learning all the time. This is plasticity. It's wonderful. So a sense that I think this idea that every sensation has to be exactly as you have it now is an interesting idea, because ultimately you relearn senses, right? I mean, we do this all the time. So the rendering, what is good enough? When's it become an information exchange question versus what I'm used to question? And so I think there's a lot of interesting directions to go, and way more than we have time for. So unfortunately, it's just wetting the whistle on all of this, I think. So I don't know, Beth, do you want to add anything to the conversation here before we go to the next question?
Well, yeah, just a couple of thoughts that I had while listening to everyone. The excitement. It's very exciting to think about having more tools to use to help with astronaut support. The idea of being able to incorporate touch as another sensory modality is just very exciting. And definitely something that we need to work towards incorporating if at all possible. The other thought that I had when you mentioned plasticity and the vestibular system, in space, the signals from the vestibular system are absent, and there's plasticity that happens in that area of the brain. That could be taken over by some of these other sensory modalities. That's another interesting thing to think about.
Great, thanks. So I know we're sadly going to run out of time soon here. I don't know, Jim, if there's a question that you think that's burning, but I do want to have a little bit of time to talk some about the ethics side of this a bit too in this shift, right? As technologists, we get excited about the technology, but I think we should not consider some of the ethics and other aspects of this tech. So Jim, I don't know if there's another question you want to ask from the audience first. I don't want to preempt the audience either.
Yeah, so actually, maybe just touch on this one really quickly, because it came from a couple of people in different forms, but it's about learning and training, about learning the use of this technology and how is that impacting the astronaut or anybody else training, and what are the big challenges there for them, and that we've seen so far and that might be anticipated going forward. So maybe let's start with Veronica. Have you seen anything in that area?
Well, I think of learning on different scales. So training could be very task specific and very short time scale. I also see learning on a longer time scale. I think about advancing learning and having global impact as, maybe enabling our physical robot avatars to tap into this global talent. There's a quote attributed to Leila Janah that talent is equally distributed, but opportunity is not. And if we could tap into that global talent and give people with diverse capabilities, ideas, life experiences access to education, healthcare, work around the world, I think, I'm not sure if I'm addressing the specifics of the question, but it was that learning part and the lifelong learning that really connected with me on that question.
Maybe Dr. Polk, you've had a lot of experience with telemedicine, and particularly we've probably a lot of learning of new approaches over the last year and stuff, as well as in healthcare. I wonder if you might address that question.
Yeah, I can tell you the astronauts learn quickly on everything that we throw at them, and they've used virtual reality on how to do spacewalks for years, and they are using virtual reality now on the ISS, and so I'm not too worried about their ability to learn those. What you do worry about is they have to learn so much on all of these engineering systems for the ISS. And if you can imagine, it's going to be probably 10 or 20 times more as we go on to Mars. Keeping all of that information at the ready is difficult. So being able to, at your discretion and leisure, being able to retrain yourself on something or review something, I think is just really important. And so, we always have that discussion. It's like riding a bike, but unless you've ridden a bike, you don't know what to compare that to. So you've got to always at least experience it once to be able to have that muscle memory. And I think that's going to be paramount for the astronauts to make sure that they can, at their demand, respond and get retrained on something as they feel they need to.
So Chris, I know HoloLens and, like here at Case, for example, holoanatomy has been used to replace cadaver anatomy. And I think there's other examples of learning using the augmented reality. I wonder if you might want to comment on that.
Sure. We have a frame of reference I like a lot called tech intensity. And I think tech intensity probably for astronauts is like breathing. It's like so natural given their requirements for learning across systems. But if you kind of zoom out from that, it is a microcosm of a recurring problem that Dr. Polk mentioned of retraining, of training, of evolving systems. And so we focus on ease of use as a primary design consideration, accessibility, different populations of people, inclusivity by design. We also focus on user interfaces and bring in those design principles as part of the way we fashion systems. If you look at the recent Windows 11 announcement, you'll find lots of improvements to the user interface that allow for things like retraining and accessibility, learnability, finding things again. And also I think that, the tendency might be to think of domain, tech experts versus novices or something. And I think that's the wrong thinking. I think it's instead about tech experts and domain experts. The domain expert may not know a lot about the system that we're talking about, but they may know a lot about anatomy. And so just learning how to interface that system with the HoloLens gives them the ability to access all of those details quite quickly and then navigate, more seamlessly. And so I think in a way, if we can address this problem of training and retraining of astronauts, it'll spill over into all of the other populations that we care about because those same problems occur at different scales. And I think it's an important problem to address from a sense of, just workability.
This is great. There's so many other things I want to go down, and how is this technology going to spill over from space to every day is a great area, but we don't have time to address that, unfortunately, this panel. I do want to touch back. One thing I want to end with, is we're running out of time here, is what both of you have brought up, Dr. Santos and Dr. White, but I want to explicitly ask it and get a, for our time, quick answer. But, ultimately, we're talking about the future in which humans embody robot avatars everywhere, et cetera. Both of you talked about, and just if each of you can address sort of how do we use technology not to separate us and sort of the digital divide that divides out. We've seen this over and over, even for who has internet during the Zoom period. How do we see this technology, or what we can do for, both in space exploration, but in general, leading to equity, diversity, and inclusion? How do we keep that at the forefront? So Veronica, maybe I'll start with you.
Yeah, I like to go back to the education, healthcare, and work. I mean, I envision a future where medically vulnerable populations can get out into their communities and participate in activities like going to school, going to cultural events. I envision clinicians being able to provide round-the-clock healthcare and do so in quote-unquote medical deserts. And workers might not have to be separated from their families, sometimes traveling overseas for years in order to support their families financially. I think these are ways to more closely connect our global community.
Great. Chris, maybe real quick on the equity and diversion and inclusion.
Yeah, it's a really challenging topic. So I was trying to kind of organize my thoughts quickly here. I guess ultimately I want to make a couple of points about inclusive design. There's this great phrase now, not about us, without us. And that to me means that it requires intentionality as technology providers to include the design perspectives of users of technology from different populations as part of the design process throughout, with the intention to generalize. As you said about spillover from space into general use, there's a spillover from specific design considerations into the broader population. And the more that we do that across specific populations, the better our technology will focus for and function for everyone. And ultimately, it's about resilience, about societal resilience. And we learned these lessons during COVID. Physical dislocation, intermittent connectivity, unequal access to resources, technology resources. And that allows us now to then reapproach design, not from a perspective of productivity or efficiency, but from one of inclusion and resilience. And I think that will create better systems that function or more reliable and let us avoid some of the issues we've seen in the last 18 months.
That's great. And unfortunately, I keep getting the message now that we're down basically out of time. This is fascinating. I really want to thank this panel of really great thinkers in this area and stuff that's going forward. And I really appreciate this conversation. I wish we had another couple hours to continue on many things, but hopefully we can continue this outside, both for the panel as well as the audience. For those that joined us, I want to thank you for your time, and hopefully we got some look to the future and thoughts going and where it's at. So thank you, everybody. I appreciate it.
Thank you all. Thank you so much. Yeah, I do wish we had a lot more time. We've got much more to talk about. So thank you again, very, very much. All right, let's jump over to our next session. This is a Glenn Extra speaker with Jeff George. So please click on over to that next session now.